Alright, so here's your second Math Visa video of the year. So essentially this one is going to help you in Unit 1 of Algebra 1. Today, we're going to discuss how you can find the domain and range of a graph. Alright, so domain. Remember that the simple definition of domain is the set of all x values on a graph. We're going to talk about it on a graph here, but you can talk about it from a set of points, you can talk about it from a table. So there are many other ways that we can talk about it, but with this video we're going to talk about it from a graph. The range is a set of all y values. Alright, so with inequality notation, we're going to kind of talk about what that looks like for the domain. So, since domain is x, we want all of our inequalities to start with x in the middle. And then the leftmost point, the leftmost x value goes on the left, and the rightmost x value goes on the right. You might have to use the inequalities bar in some cases when you can equal the value, but there are two cases when you are not going to use the equals bar. When you have an open circle on a graph, and when you have a graph go to infinity because of arrows. So those are two times that you're not going to use equals bars underneath your inequality signs. For interval notation, you're just going to use square brackets when you can equal the endpoint. And you're going to use open brackets when you cannot. But it's the same thing for interval notation in a sense that you are going to write the leftmost x value on the left and the rightmost x value on the right. Now the thing that's going to change with range is that you're going to just talk low to high instead. So instead, you're going to talk about a low y value. And now instead of x in the middle, since we're talking about y values, you want y. And then the high y value goes on the right side. I always think low left for this. There's really nothing for that. You kind of just have to think range is low to high, and you're using y values to help you construct that range. Interval notation, again, the same principle applies with the brackets, but you're just going to go low on the left and high on the right. Now I know with this interval notation I'm using closed brackets both times. However, you want to understand that there are some times when we're going to use open brackets. Alright, so let's actually jump into some examples. So, domain for this one. Since there are arrows on the end, this graph will extend really far to the left. Since there are arrows on this end, the graph will extend very far to the right. So my domain is going to be negative infinity to positive infinity. How I write that in interval notation is negative infinity, comma positive infinity, with two open brackets on both ends. The reason I use open brackets, I can't equal negative infinity. Now for the range, the lowest y value is going to be negative infinity because of this arrow down here. The highest y value will be positive infinity because that arrow up there. So we realize that for all straight lines we're going to have the same domain and range, negative infinity to positive. Okay, second graph. Let's talk about this oval-like shape. So the domain. When I have no arrows, I like to draw in a line to show me what my leftmost value is and what my rightmost value is for x. So in this case, it's negative 2 for the leftmost and 2 for the rightmost. For the lowest y value, it should be negative 4 and the highest y value is 4. The reason that I'm using equals bars underneath for the range here is because I can equal those values. I have that opportunity. Now, in interval notation for both of these, the domain and the range, we're going to use our closed brackets, or the square ones, because those show that we can equal those 2 points. Alright, a couple more examples. So, with this example, we want to look and see how far to the left do we think that this graph could extend. I'm going to use Desmos to help you visualize this a little bit. So, if I zoom out, I realize that this is kind of the similar graph. And if I keep zooming out, I realize that the x values keep going and going and going forever. If you keep zooming out, they'll keep pushing to the left pretty far if you keep zooming out. And if you keep zooming out, it'll also push really far to the right. So, we realize here that our domain would be negative infinity to positive infinity. In an interval notation, that looks like this, with open brackets because I cannot equal those endpoints. Now, for the range, I'm going to ask myself, can I get a low value? Do I know what that low value is? The answer, no. So, I realize that my low bound is negative infinity. Now, the highest point on the graph that's possible is a positive 5. So I'm going to use a less than or equal to sign here and put 5 as the high value. And then I'm going to make sure here that I put the 5 and use a closed bracket for interval notation. Alright, so what I want to do now is we are going to go ahead. I'm going to draw a graph for you, and I want you to tell me, as the bonus question, what is the domain and range of that graph? Notice that I'm only drawing in certain things because there's only a couple of things that are actually important here in order to understand what the domain and range is for this graph. So here's number 1. You can give me the domain and range of this graph. And then what I would also like you to do for number 2 as a bonus question, so 2 bonus points possible, give me the domain and range of this graph. Okay, thanks for watching.